Hello, welcome to Ludic Science. In today's video I will show you how to make this classic circuit. It is a variable frequency LED flasher that uses the popular 555 timer IC. The 555 is an integrated circuit which is a timer. It has two basic modes of operation. In the monostable mode, the circuit produces a single pulse whose period we can control. And in the astable mode, which is the one that we will use for our circuit with the LED, it produces a train of pulses. We can control the height of the pulse, it is basically the voltage input, and also the width of the pulse, and also the width of this period when we have zero voltage. Next time you need a PCB for your electronics project, consider using the professional services of JLCPCB. JLCPCB is the world leader in PCB fabrication. You can order online. You just need to register, upload your Gerber file, and wait a few days for your PCBs at an unbeatable price. The characteristics of the pulse train depend on two resistors and one capacitor. The train has two periods, T1, which is the time during which we have a certain voltage output, and another period T2 where the voltage is zero. The total period of the wave is of course the sum of T1 plus T2. And we can calculate the value of T1, which is given by this formula. It depends on resistor 1, resistor 2 and the capacitance, and T2 depends on R2 and the capacitance. Here you can see the full circuit. This is our 555 timer. It is an IC with 8 pins, which are numbered here, and the two resistors, R1, R2, and the capacitor. The circuit can work with a voltage from 6 to 12 volts DC. This other capacitor is used for stability of the output. And the train of pulses is produced here at pin 3, from where we make a connection to our LED with a resistor to limit the current. And I am using the resistor 2, it is a potentiometer, in order to vary the frequency of the pulses in the LED. This is the pin arrangement in the 555 timer. You need to look for a small notch at one of the ends in the case, and then you can identify the 8 pins of the timer. Okay, and here is the circuit working with a 9-volt battery. And we can vary the frequency of oscillation of the LED by varying the value of resistor 2, which is our potentiometer. We can increase the frequency or decrease it. And as we mentioned before, the frequency of oscillation is also controlled by this capacitor. I am using here a 100 microfarad capacitor, but if we change it, for example, this other capacitor is 47 microfarads. With less capacitance, the frequency increases. There the frequency is so high that the LED appears to be turned on, but in fact it is oscillating very fast. Our eyes can see the difference. Okay, that's all for today. I hope you liked this video. Thank you for your visit and see you in the next one.